Welcome everybody to my LeetCode Biweekly Contest 145 livestream. If you're here for solutions, 146 livestream. If you're here for solutions, jump ahead to 90 minutes in or use the timestamps in the video description. In a few moments, we'll be starting contests live, we'll be answering questions and giving hints in the chat. So come join us every weekend for the contest. No code will ever be shared. We never share solutions while the contest is running, but immediately after it ends, we will go through the answers for all 4 questions. So make sure you stick around. If you enjoy the LeetCode content, make sure to check out the rest of my channel. I have videos on different problems as well as the hardest problem for us from previous contests. And as usual, like and subscribe to stay up to date on new videos. Alright. We are live. Hey, good to see you back again. Welcome. Okay, we are on the precipice of starting. Just less than a few seconds. So let's get to work right away. Good luck everybody for the contest. I hope that you guys do well, as do I. And there's a reminder, I don't show the contest's problems. I don't show my code when the contest is running, so hang on, I need to turn off my alarm. As a reminder, I don't show my code while the contest is running. So if you don't see anything happen on the screen, just talk in the chat and I will get to you. Alright, first question today. Count subarrays of length 3 with a condition. Given an integer array nums, return the number of subarrays of length 3 such that sum of the first and third numbers equals exactly half of the second number. Okay, so here's the example, 12141. So sum of the first and third numbers is exactly half of the second number. So 1 and 1 is 2. Second number is 2, so that's not. Okay, so only 141. 1 and 1. 1 plus 1 is 2. 2 and then 4, half of 4 is 2. Okay, this kind of math question shouldn't be too difficult. Okay. Second question. Count paths with the given XOR value. Count paths with the given XOR value. You are given a 2D array grid with size m times n. You're also given an integer k. Your task is to calculate the number of paths you can take from the top left cell 00 to bottom right cell. Following the following constraints. You can move to down or right. Formally, okay, the XOR of all numbers on the path must be equal to k. Okay. Oh, interesting. So what is... Okay, so basically what it's saying... if I get it right, is you have a grid. You want to move from here to here. And what you can do is you can move to the right or down. So right or down, right, down, right, down, right, whatever, right? And all these grids of numbers, and the XOR of all numbers on the path must be equal to k. So XOR is exclusive OR. Exclusive OR essentially means flip the bits. Flip the bits. If it's XOR XOR means flip the bits. Okay. What's the size of, let me see, what is k? Okay. Okay. So all the numbers are less than 16. Which means they are 4-bit numbers. Okay, this is a pretty good clue. It's a 4-bit number. And k is smaller or equals to is between 0 and less than 16. So k is also a small 4-bit number. So this is important because if this is a large number, if this is like an 8-bit number, then the sort of states that we keep track of becomes very high. Yeah, so this makes it a lot easier. And then the size of the grid is 300. Okay. Yeah. So what you can do is you can sort of count the number of ways you can get to a particular square. You can get to a particular square and produce a certain XOR result. And since there are only 16 possible XOR results, this should not be hard to keep track. And you do that for all the squares. That should be, I think it should be pretty straightforward. Let me try it. Famous last words as usual. Let's see. In fact, you can do this almost like row by row. One way you can do it is like row by row. So you calculate the possible ways to get to each of the 16 states for all of the rows, all the squares across the row, and then you proceed down the row. That might be a more systematic way of making sure you get to every single square. And then once you get to the end, you know the answer. Okay, and the size of the grid is larger than 1. Okay. Okay. Let's see, is there any questions? No questions so far? Remember, if you have questions, make sure to ask. Make sure to ask in the chat. If I'm not saying anything, it's because I'm working on coding on a different screen. So don't panic. For column in Hey, BGM official gamer, welcome. So I don't put the answers on the screen. If you have questions, you can ask in the chat. I will describe the answer to you, but I will never show code on the screen while the contest is running. But we will go through all the solutions after the contest ends. So make sure to stick around, or you can also work on the solutions yourself, and then we'll discuss it. But in this channel, we don't show code on screen ever. That's the rule. At least not while the contest is running. But you have questions, make sure to ask, and I will. Questions, make sure to ask, and I will discuss it on screen. Alright, welcome. I see more people in the chat. If you're wondering why I'm not saying anything, I'm not doing it on the screen, that's because I'm working on a solution on another screen. We don't show code in this channel. If you have questions, make sure to ask. Right now I'm working on question number 2. It's not super hard, but it's a bit of a slugfest. If you have questions about what the question is asking, or your questions about what ideas to, what direction to go, I can give you some hints on that. Alright, let's see if this works. A real range. Real range. What is this real range? Okay. I've not solved much my question. Welcome, Cherry. Yeah, so the questions in contest, is this your first contest, Cherry? Questions in contest tend to be a little bit harder than most questions you either encounter in real life, or as part of your job, or in part of your school. Don't worry if you haven't solved questions that are this difficult. If you can solve question 1, that's pretty good already. And over time, you can sort of learn to get better at this. Honestly, I'm also trying to learn to get better at this. Contest questions tend to be much more difficult than the real programming problems that I'm used to solving. So I'm also trying and see what's the way to do this better. But don't worry too much if you don't get it right. It happens to all of us. After Zor. Okay. One. Okay. I'm currently fixing bugs in my program, trying to get it to work better. How are you guys doing? Which questions are you guys up to right now? Put it on the chat. I'm always curious how far people have gone. Hopefully you're doing better. You're doing well. Alrighty. Okay, let me see if this is right. After Zor is 1. Let me see. After Zor should be 0. Zero. Let me see. I've used BFS, but got TLE. Which DFS are you doing? Yeah, you can use BFS for sure. You can use BFS for sure. You can use some kind of dynamic programming. I'm using some kind of dynamic programming. So once again, in this channel, we don't share code, not while the contest is running. But after it ends, we'll talk about solutions. During the contest, we don't share code. So this is not one where people will distribute solutions. Oh, you're doing question 4 right now? That's pretty cool. That's pretty cool. I've not done question 4 yet. So you're going to be a little ahead of me. When I get there, I'll try to help you. But in the meantime, hang in tight. Okay, cool. Any ideas for 4? Let me take a look at 4. Given an integer nums, find the number of subsequence of size 5 nums with unique middle mode. Since under blah blah blah. Okay. We're gonna look at 4 later. I'm gonna focus on my part of the focus on the parts that I'm currently working on right now because it's still going. Let me see. It is still going. So 1 XOR 5 is going to be 4. And then what is 3 XOR 5? 5 is... it'll be 6. 4, 5, 6. Okay. Okay, so I'm doing something wrong here. Okay, let's try this again. 350, 350. Okay, perfect. I think I got it at last. Okay, oops. I hit the mod thing. I got caught by the mod again. So folks, remember that the answers for these for some of these questions have to be modded. So remember to do the mod. I forgot about mod and I got dinged for that. It's very unfortunate. Yeah, I don't actually know why they do the mod. Alright, at last. Alright, finally got that over with. Now let's look at question 3. You're given an integer n representing dimensions of n by n grid with origin at the bottom left corner of the grid. You're also given a 2-dimensional array of coordinates rectangles. Where rectangles I is in the form x. Okay, represent a rectangle on a grid. Each rectangle is defined as follows. Start and bottom left, top right. Okay, so rectangles. So 0, 0 is on the bottom left. 0, 0 is on the bottom left. Note that rectangles do not overlap. It's your job to determine if two horizontal or vertical cuts are made on a grid such that each of the 3 resulting sections contain at least one rectangle. Every rectangle belongs to exactly one section. Okay. So basically we have a bunch of rectangles. And then we want to cut them. We want to cut them such that the rectangles belong to... Okay. We have a bunch of rectangles on the map. We want to check if we can cut either horizontally or vertically. And the way we want to cut is just down the middle like this. So this will be vertically, or horizontally will be like this. Such that every rectangle belongs to exactly one. So the idea is the cuts cannot overlap. The cuts cannot overlap. And every section has at least one rectangle. So you cannot have like no rectangles. You cannot have a cut like this. You cannot cut like this. Yeah, that would be cheating. Okay, so probably what you want to do is to separate this horizontal cuts and vertical cuts into 2 different problems. Essentially, what you probably want is if you're thinking of horizontal cuts, of vertical cuts only, you want a vertical cut. Then you can think of rectangles as like overlapping ranges. This is one rectangle. This is a rectangle. This is a rectangle. This is a rectangle. This is a rectangle. Then you can think of and these 2 places can be your cuts. So essentially, you can think of them as overlapping ranges. Excuse me. You can think of them as overlapping ranges, and you want to see if you can find 2 places where you can cut. I think this should be a pretty straightforward problem. You want to turn it into some kind of range. You want to do some kind of sort, and then you find the cuts. So for second one, it's not. So I didn't use BFS or DFS. Basically, in each row, you just calculate. Okay, because BFS and DFS, I think depending on how you do it, you might end up in some kind of TLE. You might end up in some kind of TLE. So basically, what I do is for each row, I calculate. There are only 16 numbers when you do the XOR. Each number is from 0 to 15, so when you XOR them, the result is from 0 to 15. So for each of the results from 0 to 15, how many ways are there of getting there? So you calculate how many ways are there to get it up to each of the 0 to 15 for each of the squares in the whole row, and then you do the next row. So at every cell, you can either you can get that cell by coming from the left or coming from the top. You need more help on that, I will show the answer. I will talk about it, solutions at the end of the contest. By the way, sorry if my voice sounds weird because I'm actually a little bit sick today. I'm not contagious, guys, so don't worry about it. Okay. Let me make sure. Okay. Yeah, thanks, I. Yeah, my throat is really bad today. Question 2, 556 out of 580. So, sorry, let me just remove this real quick. Yeah, so sorry, please don't ask for solutions on this channel. We don't facilitate cheating while the contest is running. We will talk about all solutions after contest ends. In the meantime, you can try it out yourself. If you have questions, make sure you ask on the stream. So for folks getting stuck on question 2, getting memory limit exceeded. Is it because you are doing a full 2-dimensional array? Are you doing DP? So if you're doing DP, probably you don't want to do DP for the entire array. It's going to be very, very big. You're doing a queue. Oh, okay. I would not recommend a queue. I think, yeah, you'll definitely get memory exceeded. You can't do that. You got to use some kind of DP. If you do just like a regular tree search, like a queue, like a to-do list, I really don't think it's gonna work. Yeah, because you'll go back to the number a lot. And even if you don't run out of memory, you will probably run out of time. You'll be tired, TLE. Let me come back here. Probably what you want to do. So imagine you have something like this, right? Let's say it's this one. It's 215 710 0 1264. So probably what you want to do is for each of these grids, you have a DP. For each of these grids, count what numbers you can get. So in this case, the first grid, this is 2. So you can get to 2, and there's one way of getting to 2, just by starting here. And then what about this grid on here? What numbers can you get from here? You can't get to 1 from here. You cannot get to 1 from here, even though its value is 1. There's no way to get to 1 because you must start from here. So the only way you can get to this square is by starting from this square and then coming to this square. So you have 2 XOR 1. 2 XOR 1 is 3. So you have one way of getting to 3. What about 5 here? Well, there's only one way to get to this square, which is here, here, and here. So what are the options here? Well, 3 XOR 5. 3 XOR 5 is 110. So it's 6. So there's one way of getting to 6. Right? What about here? 2. There's only one way of getting to this square right here. This square right here, there's only one way, which is you go down. So 2 XOR 7 is going to be 101, which is 5. So there's one way of getting to 5. What about here? Well, now this is tricky. There are two ways of getting here. You can have 3, or you can have you can get from here, or you can get from here. If you get from here, that's one way of getting 3. 3 XOR 10. That's one way. 5 XOR 1. You can get from left to this one. So what number will you end up at here? There's only one way to get from here, and it must be a 5. So it's 5 XOR 10. One way. So basically you do this a lot of times. And then for example, this one will be complicated, right? Because there's 2 ways to get to here and 1 way to get to here. So there'll be 3 things here. It will be this 3 XOR 10 XOR whatever number is here, and then this way, which is 5 XOR 12, one way. So 5 XOR 12 XOR 6, 3 XOR 10 XOR 6, 5 XOR 10 XOR 6. So there are 3 ways of getting here. So the beauty of it is because there's only a very small number each one. You can get there. The size, the maximum number in each grid is only 16. 0 to 15. They're all 4-bit numbers. So you can keep this in a tractable way. So that's the general idea. yeah, you need to use some DP. I'm not gonna give you the specifics. You need specifics. The coding you can stay afterwards. So webstick, try your best. That's the general idea. You probably need some kind of lists, a vector. Yeah, just try your best. Actually, question 3 might be easier. Question 3 might be easier. So if you want to try question 3 first. This is a really bad code. Try question 3 first. It might help you a little bit. Actually, question 3 is super easy. So if you start on question 2, try question 3 first. Well, super easy is always famous last words. Yeah, I try not to say things like super easy. Alrighty. So question 3 actually is I think is a bit easier than the question 2. Hint of question 3: sweep line algo, maybe prefix, but the constraints are bizarre. Huh. So question 3, this is what I'm thinking. You want to think of this as you don't want to think of this as one problem. You want to think of it as 2 separate problems. First, you check cutting sideways. So to check cutting sideways, you want to get the bottom and top, bottom and top, bottom and top. And then you see if you can make 2 cuts. And then you check cutting up top to bottom, cutting vertically, which means you get all the ranges of the rectangles from left to right. So that's the general idea. So let's see. N equals to 4. Yeah. So make sure one thing you have to make sure is that there's n. So I didn't see n earlier. So n is sort of tricky. So it's possible for you to get to the end of the array, to the list of rectangles, and realize that you can make a cut right at the end. Actually, you can't. You cannot make a cut right at the end. You can only cut between rectangles. Oh, interesting. Yeah, you can only cut between rectangles. Yeah. Yeah. I forgot that. Damn it. So I forgot that you can. Yeah. Okay. I got a bug. So let's see where I got one question failed. So let's see what happened here. Interesting. I got 637 out of 693 test cases. One. Two zero. Three. 30. 43. Interesting. Am I missing something? Three zero 1 2 3 30 4 3 1 3 4 4 0 1 3 4 4. Okay. All right. Interesting. So maybe that doesn't work. Okay. So 0, 1, 1, 1, 3. Three, 4, 4. Okay, 1, 3, 4, 4. Zero, 1. Okay. Okay, I got a weird bug. Damn it, I got a really weird bug. Right top, why is it like this? I got a really weird bug. Left bottom, right top. Left. Okay, alright. So question 3 done. At last. I'm not gonna do well in this contest. I can already feel it. Okay, let me see if I can look at question 4 and see if there are any things in the chat. Okay, move on to third question. I'm doing line sweep algorithm where I can just subtract ending count. TLE in question 3. How do you get TLE in question 3? So in question 3, you want to think of the rectangles as ranges. Don't solve this as a 2D problem. Solve it as don't solve it as a 2-dimensional problem. Solve it as two 1-dimensional problems. So first you solve the vertical cut problem. You find all the sort of width of all the rectangles and you look at all the width and you see can you make 2 vertical cuts. And then you solve the horizontal cut problem, which is you find all the heights of all the rectangles, bottom to top, and then you can see, you check if you can make 2 horizontal cuts. So you solve it in 2 like separate problems. Solve it as 2 separate problems. You probably shouldn't get the TLE. I'm surprised. Yeah. So I think question 3 is much easier than question 2. If you get stuck in question 2, try to take a look at question 3 and see if you can do anything about it. Give me one moment. My washing machine is beeping. Alright. Washing machines in America are wild. When I came to America, it was the first time I found out about these like drying machines. So there's a machine that helps you dry your clothes. Because in Asia, most of the time, you just put your clothes in the sun and then it dries naturally in the sun. But Americans, Americans have a machine to dry your clothes. I always found that very funny. And which also means that when your machine beeps, you have to go move the clothes from the washer to the drying machine. Alright, let's get back to some computer science. Sorry about that segue. Subsequences with a unique middle mode. 1. Given an integer array nums, find the number of subsequences of size 5 of nums with a unique middle mode. Since the answer can be very large, blah blah blah. Oh, don't get jacked by this. I lost 5 minutes to this just now. A mode of a sequence of numbers is defined as the element that the maximum number of times in a sequence. A sequence of numbers, a unique mode if it only has one mode. Okay? So a sequence of unique middle mode if the middle element is a unique mode. Okay? So a sequence is a non-empty array that can be derived from another array by deleting some or no elements without changing the order. Okay. Wait, isn't this really easy? This is a sliding window, right? Find the number of subsequences of one or one or no elements. Okay. So it's not sliding window. It's not sliding window, guys. Okay. So what's a mode? What's a mode? Mode is the number that appears the most number of times. So for instance, if this is like 1, 2, 2, 3, 4, right? Let's say this is the subsequence. This is 2 will be the mode because 2 appears twice. Let's say it's 1, 2, 3, 4, 4. 4 is the mode because 4 appears twice. And it's a unique mode because it appears twice and nobody else appears twice. Mode is the number that appears the most number of times. So for instance, 1, 2, 2, 3, 3. No unique mode. Because 2 and 3 are both modes. And they both appear twice. But there's no unique mode. There's no one number that appears the most number of times. So in this case, there's a unique middle mode. So 2 appears, 2 is in the middle. And 2 is the mode. So this is a unique middle mode. Here there's no unique, there's a unique mode. 4 is a unique mode. But 4 does not appear in the middle. So 4 is not the middle mode. So that's what the question is asking for. So let's take a look at what, so this is, whenever I see the word subsequences, I think it's probably some kind of DP or some kind of memorization problem. Okay, I see some questions about question 3. Let me jump back to it real quick. Let me see. Question 3. Explain example 3 in question 3. Sure. Y is giving false. Yes. Example 3. Example 3. So question number 1 and 2 look like this. Example 3. Okay. Example 3. If you draw it out, all these points, they look like this. So draw out 1, 2, 3, 4, 5. Draw out the 5 rectangles. The 5 rectangles look like this. 0, 2, 2, 4. This is the first one. 1, 0. Sorry, 0, 2. 2, 4. Wait a second. Yeah, they look something like this. Yeah, so in this example, for instance, there's no way you can cut this. You cannot make 2 cuts such that they break up the rectangles into 4. No, this is not correct. So 0, 0, 2. Ah, okay. So rectangles look like this. Yeah, 0, 2, 2, 4, and then 1, 0, 1, 0, 3, 2. It's like somewhere here. Yeah, so they basically they're arranged in a way that you cannot cut them horizontally or vertically. You draw the rectangles, they should look something like this. Okay. Yeah, you probably want to look at these as a series of ranges. You want to look at them as ranges. You don't want to look at them as two-dimensional problem. You want to look at it as two one-dimensional problems. The x-axis problem and the y-axis problem. They're the same problem. Solve it twice. Don't look at it as a two-dimensional problem. Okay, unique middle mode. So length is 1000. What happens if I check all 1000 combinations? It's not gonna be fun. It's really not fun if I check 1000 combinations. Even if the 1000 combinations are super fast. Because it's 1000 choose 5. Okay, and the numbers itself is very big. So the values are very large. So sometimes it makes sense to look at the constraints. If these numbers are small, then that's a hint that you should use the fact that the numbers are small. If the numbers are large, means that you shouldn't even think about iterating over the value of the numbers. This is kind of a trick when when you're looking at these kind of programming competition problems. So deleting sum of all arrays or changing the order of remaining arrays. Okay. And they're not sorted. They didn't say the integer array was sorted. If it's sorted, it might be a little bit easier. Okay, let me think in terms of DP. So if I solve the problem for an array of length 5. Let's say I solve a problem for an array of length 5. It's a very long array. I solve the problem for 5, right? That's an easy problem. I just find out what the mode is and see whether it's a unique middle mode. So what happens if I add a 6 number? If I add a 6 number, I will have to get rid of one of these. My mode will change, and I have to check whether it is a unique middle mode. If I add a 6 number, the mode will change. The mode can change completely. Actually, not really. The mode doesn't change completely. The mode still depends on what these numbers are. But the middle element, will not change that much. So initially, the middle element is here. But if I add a 6 number, the middle element can be here. It can be here. Yeah, so the middle element can be here or here. Okay, and then check my mode. don't think this is the way, because this one blows up very fast. This one will get slow very fast. You got TLE in question 3. I'll go over it later. I don't know why you got TLE in question 3. That's quite surprising. Do you sort your ranges? You got to sort your arrays. You got to sort your ranges. Okay. So another way I'm thinking of is, okay, here's the other alternative solution I'm thinking of. Look, the length is up to 1000, right? So this is not a very big array. So maybe what happens if I pick, oh, wait a second, what if I do a frequency table? Let's say I start with like the middle. Okay? So let's say this number is 3, okay? So let's say I want 3 to be the unique middle mode. Oh, interesting. Wait a second, I think I got an idea. Let's say you want 3 to be a unique middle mode. That means there are 2 numbers here, and then 2 numbers here. Either there's like at least 2 of them are 3s, or okay, I think I got a plan. Okay, so you iterate over each of the elements, not the corner elements, but somewhere in the middle, right? At least starting from I equals to 2 or more. You say that I want to find 2 numbers to my left and 2 numbers to my right. Right? You want to count. Okay, let's say I'm this guy. I want to find 2 numbers to my left and 2 numbers to my right. Such that either on my left there are 3 cases. A, 2 3s on left. Right is anything. B, 2 3s on my right, because I'm a unique middle mode, right? I'm a middle of 5 numbers. Let's say this is the middle of 5. This is my middle guy of 5 numbers. I've got to have 2 numbers on my left and 2 numbers on my right. So if I'm in the middle, I have 2 numbers on my left, 2 numbers on my right. So if I'm also the unique middle mode, that means the 2 numbers there are 3 cases. Either both numbers on my left are the same as me, and then the numbers on the right can be literally anything. The 2 numbers on my right are the same as me, and the 2 numbers on the left is anything. Or C, there's 1 each. 1, 3 on each side. That is if they okay. Yeah, there's a few options. Basically, there's a few options. If I have total of 3 3s, so I'll have 2 on the left, 2 on the right, or 1 on each side. Or I have a total of 2 3s. That means 1 on the left. Yeah. So there's this whole list of options. So if I'm a 3, I have either 1 3 here, 0 3 here. Yeah. Oh damn. And I have to make sure that there's a unique mode. Okay. Yeah, I think this is gonna be my strategy. I don't think I have enough time to code it out, but this is my strategy. I'm gonna first create a frequency table. So for each numbers, because there's only 1,000, right? Even though the numbers can be like literally anything, there's only 1,000 of them. So for each number, each value in the list, I track how many times they appear and where are the indexes that this number appears in the list. And then what happens is I say, yeah, I think that's the plan. So for this to be a unique mode, either it occurs 3 times, or 4 times, or 5 times, or it occurs 2 times, everything else occurs 1 time. So for this to be a unique, let's say 3 is a unique mode of 5 numbers, and 3 is in the middle, then 3 either occurs 3 times, 4 times, or 5 times, which is what I'm doing here, or 3 appears twice, and everybody else appears 1 time. Okay, actually this is hard. I don't know how to do this. So if you want to check that if 3 appears at least 3, 4, or 5 times, that's not too hard. So probably I want to start with like a frequency table. I want to do like the first pass, I do like a frequency table, which is I say, okay, what are the values that appear and where they appear. That's very important, where they appear. That'll be step 1. Step 2, for all the values, I just see if does it appear at least 3 times, 4 times, or 5 times? At least 3 times, then I can check this, or it occurs twice and everything else occurs exactly once. So this one is hard. This one I don't know how to do. This one is easy. So you want you want basically choose a sub sequence of length 5, where the middle number is like x3 or whatever, and 3 appears at least 3 times. This is easy. You just do a frequency table. Yeah. How do you solve this though? The other case where I want if 3 appears exactly twice, and the other numbers occur at most once. Yeah, I had to think about this. This is like a math problem. This one is like a math problem. So if I want to find the number of subsequences where 3 is in the middle, and 3 occurs at least 3 times, which makes it a unique middle mode, I would track all the 3 and then, yeah. So actually the other thing I'm thinking about is, I wonder if I can do this. I can actually make this a bit faster. If I want to look up 2 numbers before and 2 numbers after, right? I can actually do a prefix sum. A prefix sum of the occurrences before and after. So prefix sum of the occurrences of each value. So I have a prefix sum of how many times 3 appears, how many times 4 appears, 5, 6, 7, 8, 9, 10, blah, blah, blah. And I have a one, well, it's not a prefix sum anymore. It's more like a prefix dictionary. A prefix like hash table, where in each square, okay, and that will help me figure out very quickly at index I, how many threes appear before me and how many threes appear after me. Yeah, so that'll be the first thing I do is to create a prefix, like a prefix dictionary. That's what I'm going to do. Create a prefix dictionary. So for each square, for each cell, I'm going to say how many times each number has occurred up to that cell. So for instance, if it's like a 3, 1, 3, 4, 3 appear one time. This one appeared one time, 3 appeared one time. 1 appeared one time, 3 appeared 2 times. 1 appeared one time, 3 appeared 2 times, 4 appeared one time. So you do like a prefix dictionary of the frequencies. And then using this, when I'm here, where I know that at my location, 1 occurred one time and 3 occurred twice, including myself. I just look at right at the end, how many times. This would tell me how many times any number has occurred either before or after me. So this is a very convenient data structure. This is the basics data structure I'm going to use. Some kind of prefix frequency dictionary. Okay, so this one I don't know how to do. This is the part I don't know how to do. Occur twice. Okay. You want to know that something occurred. You want to know that you occur at least exactly twice, at least exactly 2 times, and then all the other numbers are unique. Oh, yeah, actually it's not that hard. Okay. Yeah, I think actually I think I know how to solve this actually. Yeah. Okay. Sorry about that. That was a long-winded explanation for question 4. Let me see the chat. Tried it DLE. Tried 3 or 4. I can do them. I tried 3. 3 is easy, dude. 3 is easy. Yeah. No. You don't need optimal. There's no optimal solution for 3. 3 is just like the easiest, greediest brute force. Yeah. Yeah, we'll go through it later. Your bitwise solution for 2 is very clever. Yeah, thank you. 3 is default division. Maybe I should tell that way from the start. Yeah, you know what? This is sometimes it's like clever tricks. Okay, prefix sum for 4 is clever. Yeah, well, thank you. I'll go through this later. We'll go through all 4 questions later. I'm pretty sure I know how to solve 4. I'm pretty confident, but I definitely do not have time to solve it. I think I'm going to use like a prefix frequency dictionary, essentially. Okay, do people need help for question 2 and 3? I'm going to see if I can help people. Question 3, once again, if you're getting a TLE, do you sort? You probably want to sort your ranges. So probably first step is to extract the ranges. Instead of looking at them as rectangles, you want to extract the left and right ranges. You want to put them all on one dimension, and you take the left and right, left to right, left to right, left to right. Take all the left to rights, and then you sort them. That will make your life much easier. Just sort them, so you don't have to test for overlap. And then see when I can make 2 cuts. So same thing, vertical. You get all the vertical ranges, you sort them, and then you see whether you can make 2 cuts. No code will be shared, but later on we'll go through solutions for the 4 questions. And then question 2 is actually harder than question 4. Question 2, basically you construct some kind of DP table that tells you how many times you can get a specific number. That's all that I can say. Because the contest is still running. If you need more help, well, the contest is ending soon. So if you need more help, just hang out after contest and we'll talk about it. So contest is ending soon, and I want to take this time to remind people, if you haven't already, it will help me a lot if you subscribe to the channel. If you enjoy my content, you want to see more of it, subscribe to the channel. I stream every weekend. I do the bi-weekly contest if this there. If not, I do the weekly contest. I'm trying to get back to the regular schedule where I make sure I stream at least one contest every week. It will help me so much if you enjoyed the stream today to just click the like button on this stream right now. Or if you want, leave a comment on the VOD when it comes out later. So that's going to help me out a lot. Thanks folks. Contest is almost over. I'm going to take a swig of water. I've given up on question 4, even though I think I know how to solve it. I think so. Famous last words, but I think I know how to solve it. I'm going to explain my thought processes, and then I'm going to try and solve it after the contest, maybe today or tomorrow. And I will see if I can post the example solution in the what you might call it, the video description. So I'm going to share my example solution in the description for question 4. And you know, if you see my example solution before, I try to add a lot of like comments so that people can follow. So hopefully that's helpful. If you want answer to question 4, also leave a comment on the video. And people really bounced immediately after the contest. Leave a comment on the video, and I can put out a separate video for question 4 if you want. Okay, 2 more minutes. I'm gonna take a swig of water. Everybody brace yourselves. Contest is about to end. Alright, contest is over. I hope you guys did well. Hopefully you did better than me. We're going to go through the solutions for all 4 questions. I managed to do 3 questions, which was an upgrade from last time. But still not exactly where I personally want it to be. But we'll see. We'll see how it goes. But first, let me do my mandatory YouTube intro. We are discussing solutions for LeetCode Biweekly Contest 146. Jump to specific questions using timestamps in the video description. Check out the rest of my channel if you enjoy LeetCode content. Like and subscribe to stay up to date on new videos. Alright folks, contest has just ended. Let me know in the chat how well you did, how many questions you managed to solve. I hope you guys did a little bit better than me. Will still complete 3 on my own. You gave up way too easy. Yeah. Question 1 and 3 actually is not hard. Question 2 is a little bit annoying, but it's not hard either. Question 4, I will go through it. I didn't manage to finish question 4, but I'm pretty sure I know what the general strategy is. So without further ado, let's jump in. So question 1. Count subarrays of length 3 with a condition. So you're given an integer array nums, return the number of subarrays of length 3, such as sum of the first and third numbers equals exactly half of second number. Well, what's a subarray? Subarray is a contiguous non-empty sequence of elements within an array. So it's just a fancy way of saying a continuous range. So this will be a subarray, this will be a subarray, this will be a subarray. Of the 3 subarrays we have here, the first one, we have to check the length, the sum of the first and third numbers equals exactly the sum of half of the second number. So what you want to do, oh, I lost it. I want to show my solution. So what you want to do is very straightforward. You find all the subarrays. You go through all of them. So I'm doing a for loop here. I from range is -2 because these arrays are length 3. If I is the left hand side of the array, then I have to stop 2 squares below the end of the array. I just check the first one and the last one times 2. Is that equal to the middle number? If it is, total plus minus 1. That's all there is to it. So the main thing to know is a subarray is a contiguous. You can't jump. So it's, it's a sequence of 3. So question 2. So question 2, you're given a 2-dimensional array grid with size m times n. You're also given an integer k. Your task is to calculate the number of paths you can take from top left hand corner to the bottom right hand corner, either move right or down, and then the XOR of all numbers on the path must be equals to k. So the basic idea here is, let me just get rid of this first. The basic idea here is you think of this as a grid. And you start from top left hand corner, this guy right here. You can move right or down. So you can move like this. You can move like this. You can move down, right. You can move down, right. And you want to go from here to here, top left to bottom right. And you want to count how many ways you can get there, such that the XOR of the numbers on the way is equals to k. So in this case, the numbers on the way is 2, 1, 5, 7, 10, 0, 7, 10, 0, 12, 6, 6, 4. So a path might be 2, 7, 10, 6, 4. So 2 XOR 7 XOR 10 XOR 6 XOR 4. And I don't know what this is, but you want to check if this is equals this result here is equals to k. So you want to check how many ways are there of getting from here to here, such that the XOR of all of these are k. Now, when I see a problem like this, one of the first things you check is the constraints. And you'll notice for this problem that the grid, first of all, grid is not too big. Second, and more importantly, the value of each number of each number in the grid is up to 16. So it's only 0 to 15. Which means they are all 4-bit integers. The nice thing about this is then this number, there's only 16, so you can actually do something with this. This means that like you will not get an explosion of possible values that you have, right? Because there are only 16 numbers. All these numbers, you take these numbers, you XOR them, you only end up with a range between 0 to 15. So the basic idea for the basic idea for solving this problem is to count the number of ways you can get to each number by XORing them. So let me just write this again. 7, 10, 0, 12, 6, 4. Okay? So, for instance, if in this square, there's only one way to get to this square. You start there. The only value you can get is 2. So, there's one way of getting to 2. How do you get to this square? There's only one way of getting. You go from this square to this square, right? The only way you can get there is this way. And what's the value of the path to getting there? 2 is 1. So you solve 2 and 1, which will give you 3. So there's one way of getting here, and its XOR value is 3. What about this one? How many ways of getting? There's only one way of getting here, and its XOR value is the XOR value of 2 and 7. So 2 is 1, 0, 7 is 1, 1, 1. So you get 1, 0, 1, which is 5, I think. One way of getting here, and its value is 5. What about here? Now, there are two ways you have of getting here. You can come down, or you can come from the left. If you come from the left, on the left, there's only one way of getting to this square on the left, and its XOR value is 5. So you take 5, you XOR 10. So this is 5, 10. What is 10 in binary? Is 8. Sorry, 8, 2, 0. So you XOR this, you get 1, 1, 1, 1. So 15. There's one way to get here, and its value is 15 if you go from left, or from up to down. So 10 is 1, 0, 1, 0. 3 is 1, 1. So you XOR this, you get 1, 0, 0, 1, which is 9. And there's one way of getting here is 9. Right? And as you sort of expand this, because now what about this 6? There are 3 ways of getting here, and you calculate the XOR value for each of the 3 ways. Right? You calculate like your XOR value here, you calculate, and because there are only 16 possible values, this dictionary is going to be very small. Or this like hash table or array or whatever is going to be very small. So you can do that quite cheaply. Okay? If you do that, you'll be able to find what's the total number of XOR values that you get here. So some of you did like a to-do list or some kind of queue. That will almost guarantee you to that's not a good idea, because you're almost guaranteed to TLE. You're almost guaranteed TLE. When this becomes very large, the branching factor is very large. That will not be a good idea. Instead, what you could do is you could just use some kind of dynamic programming. You want to do some kind of dynamic programming. So you create, so what I do is basically I calculate row by row. I calculate the XOR value dictionary for the first row, or XOR value hash table for first row first. And then I calculate for the second row. So to calculate the XOR value for first row, I just start with the left hand corner, right? And then for each of the other cells, your value depends on the value before. So this is what I'm doing here. Ignore the debugging lines. I start from the left hand corner. The top left hand corner state grid 0, 0 equals to 1. So this is a value. In this case, it'll be 2 equals to 1. There's one way of getting to 2. And then for the rest, I calculate, right? For I in 1 is 16. This is why the number of states have to be very small. If the number of is like, this is like 8-bit integer, this will never work. It only works because it's a small 2-bit integer. This is 2. And 2 XOR 1 is equals to 3. That's a new XOR value. I call it after XOR. And I increment the counter for this. So this thing will do basically is it will set 3 to 1. There's one way of getting to here, and with a XOR value of 3. Okay, and after that, for the rest of the rows, it's basically very similar, except that in addition to coming from the left, you also come from the top. So from the top is basically the row, the column, plus minus the previous row. So here I basically, instead of creating a 2-dimensional DP array, I create a one-dimensional DP array for my current row, and when I move on to the next row, I use the previous row. I swap them. So at the beginning, this first row is state, and then my new row becomes state, and then my new row becomes state. At any point, I only keep 2 rows. Yeah, that makes my life much easier. That saves a lot of memory. Otherwise, you keep like a 2-dimensional array. This can be very large. I only keep 2 rows, the current row I'm acting on and the previous row. So state is the previous row, state 2 is the current row. So I have the current row and the previous row, and that's enough for what I want to do. Yeah, and then at the end, what I do is I look at the very last row. I look at the very last cell of the last row, and I check how many ways are getting there such that your resolve value is k. So that's basically, yeah. Let me look at the chat. Sorry. Solve 2 out of 4. Nice prototype. Very well done. Yeah, I hope you'll be able to do 3 after I go through. So Nash, hey, how's it going? I managed to do 3 this time. Yeah. Hopefully can do it better next time. Maddox, welcome. What's up? What's up? I did 3. What's up for you, Maddox? How many did you do? Solution looks good. I use 2-dimensional array. Yeah, you can use 2-dimensional array also. I use 2 rows, so I save a bit of like memory. Third question, you also got TLE. Interesting. DP plus DFS. Yeah. DP plus memo. Yeah. I'll go through question 3. Question 3, I'm surprised you guys got TLE, because I thought question 3 shouldn't have a TLE. I'm curious. Yeah, let me know how do you guys end up with TLE? Bit curious. Alright, question 3. Check if grid can be cut into sections. You're given an integer n representing dimensions n by n grid with the bottom and the bottom left corner. You're given a 2D coordinate of rectangles where rectangle I is in the form blah. So you're given a bunch of rectangles. The rectangles don't overlap. And what you want to do is either make 2 horizontal or vertical cuts on the grid such that the resulting sections contain at least 1 rectangle and no rectangle contains more than 1. So for instance, let's say this is the rectangles. You can make 2 horizontal cuts here, divide them into 3 sections. Each section contains at least 1 rectangle, and they don't overlap. The cuts don't go through rectangles. Note that you cannot make 2 vertical cuts in this example, right? There's no way to make a vertical cut. You cannot cut here, you cannot cut here. There's no way to make a vertical cut that doesn't slice through at least 1 rectangle. So horizontal, you can make 2 cuts. Vertical, you cannot make any cuts. Let's go on a little bit. This one is the same thing. So horizontal, vertically, you can cut like here and here. Notice that you can actually cut on the rectangle itself. You cut on the rectangle is fine. It's perfectly fine, right? Even though the rectangle is touching the cut. In this example, you cannot cut horizontally. Because you cut horizontally, you're going to hit someone. You're going to hit someone, and you don't want to do that. Yeah. And then finally, for this one, if you draw it out, it's like a 0, 2, 2, 4. 0, 2, 2, 4. It's like this. You draw it out. I think it looks something like this. So for example 3, you draw it out. I think it looks something like this. And in this example, there's no way you can make any cuts. Oh, you can actually make a cut here. But there's no way to make 2 cuts without going through some rectangle. So that's the basic idea. You want to see if you can make 2 cuts either horizontally or vertically, such that you can divide the rectangles, such that they don't like slice through any rectangle. Okay, so how do you do this? Well, if you think about it, you don't actually have to think of them as rectangles. You can think of them as ranges. You can think of these guys just as ranges, And then instead of solving a two-dimensional problem, you solve two one-dimensional problems. So for instance, in this case, you can think of this as a range, this as a range, this as a range, this as a range. Okay? You have 4 ranges, and you want to see if these ranges can be broken up into 3 groups with the 2 cuts. So likewise, you can also think of them vertically. You can also think of them vertically, right? You can think of this as a range, this as a range, this as a range, this as a range. Now you have again 4 ranges. You want to see, can you slice these 4 ranges into 3 groups? Okay? So instead of solving the 2-dimensional problem, you want to solve the 1-dimensional problem twice. That's the basic idea. And I would say that question 3, at least I felt it was a little bit easier than question 2. So the first step is I want to check vertical cuts, and then later on I want to check horizontal cuts. The code is almost the same. If I'm doing a real program, I'm probably going to refactor this in a function, but in a program context, I don't care. So first, vertical cuts, I'm going to extract the ranges. Left, bottom, top, right. That's what I have in rectangles. Right, this left, bottom, top, right. Left, bottom, top, right. I'm going to append left and right as a range into ranges. I'm going to start with left to right first. These are horizontal ranges. I make vertical cuts on the horizontal ranges. This is a key thing. I sort them. I want to sort them by where they start. So in this case, for instance, in this case, I want to sort them by where they start and where they end. If you don't sort them, they're all over the place, and then it becomes tricky. So if you sort them, then the question becomes much easier. First, you check the range. What you want to do is you want to check whether they are cuts, right? What does the cut mean? The cut basically means that the start of the next range is after the end of the previous range. If the start of your next range, you sort them by the start point, and the start of the next range is after the start of the previous range, then you can make a cut there. So for instance, here, this one and this one, you can make a cut. You can make a cut between them, right? You can make a cut between them because you can make a cut between them because the start range is before the end. But here, the end is here, so and the start is here, so you can make a cut here. So that's all you have to check. You sort them by start. You sort them. In Python, this will sort by the first number, which is the left number. And then you check where's the previous, right? You start with the first rectangle. Its previous range is 0. The previous end, the last endpoint that you see. And then you go from the rest of the ranges. You check whether your start is greater or equal to the last end. If you are, you can make a cut here at the start. If you make 2 cuts, you're done. If not, then you move the end to the max of the previous end and your end. So what that means is like this. If your first range is here, your second range is like here. This is the start, right? This is the previous end. Does it match? No. So you move the previous end to here. Your next start is like here to here. So is this start, previous end is here. Does this start, is it after previous end? No. You still can make a cut. You can make these are vertical cuts, right? You can make. Where's the next previous end? Well, you take the maximum, which is this one. So it's still here. It doesn't move back here. So your next one starts from here. Your next start now is now greater than the previous end. So can you make a cut? Yes. This will be cut 1. And now your previous end will move to here. And then you keep going. And then maybe the next one is here. You still can cut. But the next one is here. Then you can make a cut 2. So that's the idea. And once you've done that for your vertical cuts, you can repeat the same thing for the horizontal cuts. This way, it's the exact same code. I just copy and paste. The ranges are now bottom to top. That's the only difference. And you do that, you'll be able to find if you can make a cut, you make 2 cuts either way, it's true. If not, you return false. So that's all there is to question 3. Let me just read the code. Question 3 was merge intervals. Binary search. Yeah, I know. Sorry, prototype. Medics, that was just sorting 2 cuts. Yeah. Try today's daily streak. Yeah, I haven't done it yet. I intend to try it. I'm going to try it right after this. It's very fun to solve. I did 3 was easy. I could have used a set and put internal index. Yeah. Just iterate over the n. What's max and interval index? Yeah. Binary search for second. Oh, you don't have to do that. Yeah. You don't have to do that. You can. It's the log n solution. Binary search. I'm surprised it doesn't work. Yeah. Yeah, 10 to the power of 9. Yeah, 10 to the power of 9 is a big number. So 10 to the power of 9. So the general trick is, you see 10 to the power of 5, you cannot do n squared. 10 to the power of 5 means it has to be better than n squared. You see 10 to the power of 9, it has to be linear, or sometimes even better than linear. When you see 10 to the power of 9, linear doesn't work either. So it has to be sublinear, which, yeah. What do you think of the set solution? What do you mean by set solution? Yeah, sorry, I didn't see a set solution. Okay, cool. Let's move on a little bit. Question 4. Question 4. I didn't actually get to try question 4, but let's go over it. I'll try my best. I think I know a strategy. Fingers crossed. I think I know a strategy for solving this. Wait, let me read chat first. If a rectangle starts from 0 and end at 5, store in set so that at index you can place a cut. Oh. Okay, so the problem in the set solution is that... Actually, I don't know. Let me see. The set solution might work because... Oh no, the set solution will not work because of this. Because the size of rectangle can be very big. Right, so your first rectangle is 0 to 1 million. Or in this case, this is not even 1 million, right? This is 1 billion. 0 to 1 billion. The first thing you do is to put the numbers 1 to 1 billion in a set. And so that's not going to be fun. Yeah, I don't think that will work. Yeah, you end up adding too many times if you do that for a set. Okay, let's talk about 4. I think I know a strategy. Okay, subsequences with a unique middle mode I. Given an integer array nums, find the number of subsequences of size 5 of nums with a unique middle mode. Since the number can be blah blah blah. A mode is a sequence of numbers. It defines the element that appears the maximum number of times in the sequence. So number is a unique mode if there's only one mode. So for instance, just to give an example of mode, 1, 2, 2, 3, 4. Okay, the mode is 2 because it appears twice, and is unique because no other number appears twice. 1, 2, 3, 4, 4. The mode here will be 4. Because 4 appears twice, no other number appears twice. If it's something like 1, 2, 2, 4, 4, the mode, I don't know what the actual definition is, but in this case there's no unique mode because 2 appears twice and 4 also appears twice. So if your number appears 3 times, it's guaranteed to be a unique mode. Nobody else will beat you. If you appear twice, you might be a draw. If you appear 1 time, you cannot be mode. So those are the rules. In this case, we're interested in a unique middle mode. Unique middle mode. Yeah, the middle element is a unique mode. So here, this is a unique middle mode. Yes. This one, no mode, so no. This one, mode, but the mode is not in the middle. This 3 is not a mode, so this is also no. So only the first sequence has a unique middle mode. It has a 1, it has a unique mode, and 2, that unique mode is the number in the middle. So that's what this question is looking for. It's looking for a subsequence. Subsequence is different from subarray. Subsequence is you can pick any integer, any number from anywhere. You just cannot rearrange them. So for instance, in this case, 1, 2, 2, 3, 3, 4. So 1, 2, 2, 3, 4, 1, 2, 2, 3, 4. You can jump. You don't have to be contiguous. And 1, 2, 3, 3, 4, 1, 2, 3, 3, 4 are both subsequences with unique middle modes. You can jump or you can sort of skip elements. You don't have to be 5 contiguous numbers. Okay. So I thought about this during the stream. The idea that I came up with is I'm going to think about the middle number. If I have a bunch of numbers, and let's say this number here is a 3, the question I'm going to ask myself is, if this 3 is the middle number, how many subsequence can I have where 3 is a unique middle mode? So if 3 is the middle number, I need 2 numbers on the left and 2 numbers on the right. And the 2 numbers on the left, there's a few conditions that to satisfy. Either 1, 3 appears, or A, 3 appears 3 plus times in total in the 2 separate, which means that you can calculate this actually. So depending on how many times 3 appears, the number 3 appears, you calculate, okay, if 3 appears like 1 time, 2 times, 3 times, whatever. 3 appears 3 plus times out of these 4 numbers. Or B, 3 appears 2 times and everyone else one time. Okay? So if A, 3 appears 3 plus times, there are a few cases, right? Either 3 appears exactly 3 times, which means on the left, it appears 2 times, on the right appears once, on the left it appears once, 2 times, right appears 0 times. Yeah, so there are 3 possible cases. If you want 3 to appear 4 times, then it has to appear 2 times on the left, 1 time on the right. If you want 3 to appear 5 times, it has to appear 2 times on the left, 2 times on the right. So this is a bunch of cases. And for each case, you calculate this. And then for 3, you need it to appear exactly twice. That means it has to appear exactly once on the left and 0 times on the right, or vice versa. And everybody else must appear at least once. Exactly once. So you can again calculate that. So this is basically a combination and permutation problem. The only tricky thing is, when you're here at this index, you need to know how many times 3 appeared on my left and on my right. So you need a data structure that allows you to do that very quickly. You need a data structure that at any index tells you how many times did any given number appear on the left of me, how many times did any given number appear on the right of me. So to do that quickly, I think the best way is to have some kind of prefix dictionary. Not a prefix sum, but a prefix frequency dictionary. So what I mean is something like this. So let's say 1, 2, 2, 3, 3, 4. Okay? So at 1, I say 1 appear twice. At 2, 1 appear once, 2 appear once. Okay? 2, 1 appear once, 2 appear twice. So you sort of do like a prefix frequency dictionary. There are optimizations. You don't have to do this the whole time. I think you don't have to keep every single dictionary. You probably have to keep only the one at the end and your current one. And then 4 is 1, 1, 2 appears twice, 3 appear twice, and then 4 appear once. So if you're here, you want to know how many times 3 appeared on my left. I just look at this. I subtract myself. Obviously, I ignore myself. I see that 1 appears once and 2 appears once. If I look at my right, I can take the very last frequency dictionary and subtract myself. So 1 appeared once, 2 appeared twice. So I know on my right, 1 and 2 did not appear. 1 is 0 times, 2 is 0 times, because this minus this is 0. 3 appeared once, 3 appeared 2 times at the end, and up to myself, it only appeared once. So 3 is once, and then 4 appeared once. So I'm going to use some kind of prefix dictionary. And the thing is, you don't actually have to keep all the dictionaries. Actually, you just need the last one. So probably what I would do is I would calculate the frequency. I'll calculate the last one first. And then on my second pass, as I'm iterating over the array, I create the current dictionary. So the basic idea is I have one for loop that goes from here to here. And then I say if this current index I is the middle number, if this current index I is the middle number, how many subsequences can I form with this guy as the unique middle mode? That's the math problem I'm going to solve. Okay? So now I have a way of quickly calculating how many numbers appear, of which type of numbers appear on my left or right. I can use that to calculate my unique middle mode. So for instance, in 3, let's say I'm here. I know that 1 appeared once and 2 appeared once. Okay? I know that I am 3. I need 3 to appear. Let's check the A case. 3 appears at least 3 times. Is it possible for A to have at least 3 times? No, because I'm 3. On my left, there are no 3s. On my right, there's only 1 3. So this is not possible. So let's look at this case. So if 3 appears at least once, okay, so 3 appears 2x, well, one time I'm going to pick this, right? So there's only one possibility. And then everybody else have to appear exactly once. So what's the probability that everything occurs exactly once? Well, I pick everybody that is non-zero and not 3. And I do n choose 2. So in this case, I do n choose 1. So in this case, I know I'm middle. I have a 3 appear on my right. I'm going to take, there's only one number 4 here that appeared more than once. I'm going to choose 1 because there's only one space left here. I need 2 numbers here. On my right, I have 1 and 2. So I have 2 different numbers. And I need 2 numbers to appear. I have 2 numbers that occurred twice, at least once on my left. That is not me. So 1 and 2 both occurred at least once on my left. That's not me. I need 2 numbers on my left. Since I'm the unique middle mode, I'm the middle of 5 numbers. I need 2 numbers on my left, 2 numbers on my right. So I need 2 numbers on my left. So 2 choose 2. So that's the basic idea. I think that will work. So on the left, 2 choose 2. On the right, I have a 3. I have a 1. This is what I want. It appears exactly 1. Then 1 choose 1. Okay? What if 3 appears multiple times? Let's say it appears 3 times, right? Then I will just take 3 times 1 choose 1. If there's a 5 and 3 threes on my right, and there's like a 4 and 5, then this becomes 3. If I want a 3 to appear on my right, it occurred 3 times. I can pick one of them. So it's 3 times. There are 2 numbers that occur at least once. 2. And I want one number to appear once. Choose 1. So it's 3 times 2. 6. 6 possible combinations for all the numbers here, such that there's exactly 1 3 and exactly anything else. So that's this. So this is the math part. This is the math part. This is the data structures part. So the data structure here you want to use is some kind of prefix frequency dictionary. You first calculate the total number of frequencies of all the numbers, and then you don't actually have to keep all of these, because you're going down. You have a for loop that goes down, right? At each for loop, you keep track of all the frequencies that you have seen so far, and that will tell you how many times something appears on your left. You take the total, you subtract yourself, that'll tell you how many times something appeared on the right. And that will be, I think that's the trick to do it. Yeah, it's some kind of prefix dictionary. Yeah. Okay. So, you read 4 and close the contest? Yeah. Yeah, sometimes it's challenging, right? Dude, it's challenging. This is not hard. This is not easy. But here's the thing. I think contests help us in 2 ways. One, it stretches our brain. It stretches our brain and force us to think of like clever ways to solve problems. I bet you never thought about this kind of prefix dictionary until now. Secondly, in terms of like real life software engineering, some software engineering solutions are fairly complicated. It's very unlikely in your life that you would have to write more than 1 or 2 very complicated solutions. But you probably have to read a complicated solution somebody designed many times. I think I made many, in the past 10 years when I worked at Google, I think I made at most 1 or 2 clever solutions that look like this. But I've read clever solution written by somebody else many times. So having these kind of contests and having your brain get stretched by more advanced data structure, more complicated algorithms, forces you to be better at sort of keeping track of visualizations in your head. And I think it's good practice either way. I don't think that any sort of interview questions will ask you something like this. I think that's very unlikely. But it is good exercise, good practice. I hope that was helpful. Yeah, well, yeah, thanks. I try to explain. Yeah. So here's the thing. You can read other people's code. You read other solutions on LeetCode. They're hard to understand, right? Because people don't really do a good job of like breaking down what their thought processes is. In real life, a lot of code they write will look like other people's code that they just copy and paste there. It's not fun to read those kind of things. So if you have practice sort of visualizing these things, all you need is a little bit of hints in their code and you can start visualizing things on your own. You can sort of go back and forth. You can read their code and then you go back to your own mental model and check, and then you go back and forth. And that's how you would do it in real life. But thanks a lot. I appreciate your kind words. I try to make my explanation accessible to everyone, even though I would say this is a fairly complicated problem. So I'm glad that you guys like it. Okay, cool. So that brings me to the end of the contest. Thanks everybody for showing up once again. If you enjoyed the channel, like and subscribe. It's gonna help me out so much. And I hope to see all of you guys come back next week. Adios. Bye.